Good morning and welcome to our recording of our Buzzing with Monarchs program. This will be part one of our program done by me, Bob Bruner. I am the A&R Extension Educator with Purdue University in Clay and Owen counties in Indiana. Part two will be a separate video done by Tabby Flynn, A&R Educator in Vigo County, Indiana. This morning, I want to talk to you a little bit about some of the unique features of the monarch butterfly. So this particular insect has a special place in our hearts. We love its colors. We love how it comes to visit us every year. There are very few people in Indiana who haven't seen a monarch because we represent a great stopover location for monarchs on their migration. And because of that special place they hold for us, we want to protect these insects. Unfortunately, human activity has reduced some of their populations to the point that we make sure to protect them as best we can through volunteer work and different kind of wildlife preserves. We're going to go over a lot of this information a little bit later on in the talk, and Tabby will be covering some ways that you can help improve monarch preservation. But for right now, let's look at some of the interesting facts about their biology and migration behaviors. So the first thing to understand about monarchs is they belong to a special group of insects known as Lepidoptera. I'm an entomologist myself, and I know that as an entomologist, we love to categorize things. We usually categorize insects by common features that are shared by all members within a given group. In the case of Lepidoptera, we look at their wings. What they share in common is that they all have scales on their wings, which is what that Latin name means, lepido meaning scale, ptera meaning wing. They also have a particularly unique development cycle. They go through the normal egg, larva, pupa, adult cycle, but they migrate throughout it and can have multiple generations within a year as they do their migration. And I'm going to go over that in a little bit more in detail. So first off, let's look at some of their more unique biological features. In this case, we're looking at a close-up of the scales on their wings and their bright colorations. If you've ever had the opportunity to handle a moth or a butterfly and you've got your fingers on their wings somehow, you probably noticed that they came away with some kind of funny powder on the tips of your fingers. These are the scales of this insect. They rub off very, very easily, and if you rub off all the scales on the wings of a butterfly, you would find kind of a clear membranous wing underneath. These scales serve a unique purpose because that's where we get the color of our different butterflies, including our monarchs. These colors are very bright, they're very noticeable, which makes them one of the many reasons why we love seeing them every year, year after year. Now the reason that they have this color is because they have a unique trait. Butterflies usually eat plant material in their youth when they are caterpillars. In the case of monarchs, their caterpillars will specialize entirely on members of the Asclepius species, or the Asclepius genus I should say, the milkweed, and there are several different kinds of milkweed that they can feed on. Milkweeds have a kind of toxic sap that is actually dangerous to most animals. You can't consume it without getting very, very sick, and in some animals it could actually kill them. However, what monarchs do is they go ahead and they consume that secondary compound, that toxic chemical the plant produces, and they sequester it away in a portion of their body. Basically, they take it and they just put it in a box inside their body, and they never touch that box. It doesn't go through any kind of breakdown. It doesn't go through any other process other than just being stored away. What happens is as the monarch develops through the caterpillar stage and into the adult, that sequestration continues to remain there and it gets moved into the scales of their wings, which is where that bright color comes from. That bright orange you see is actually the color of cardolinites, which are the toxic chemical that they're sequestering. Here you can see a great example of it in our immature monarch, the caterpillar right here. You can see this little guy eating a milkweed plant right now. That bright coloring comes from him sequestering away that chemical, protecting himself and not actually digesting it. He's just putting it in a place in his body, and it's producing this really bright, really noticeable color that's going to stand out no matter what. Now this means it makes them very, very visible. Now, since they're so visible, that means that they're going to be obviously noticed by predators. Well, the reason they want that to happen is because this represents warning coloration. Since they aren't breaking down the cardolinites in their body, that means that those toxic chemicals are still there. Any predator that's going to consume a monarch is going to find it to be extremely distasteful or potentially poisonous to them. So that warning coloration sends out a message that says, if you eat me, you're going to be in trouble. So it serves a great purpose for them. They can continue eating a plant they specialize on that not many animals will, and they get the added benefit of being protected from predators and other animals. Now, like a lot of our different butterfly and moth species, they have a unique way of feeding when they are an adult. What they do is they have what entomologists refer to as siphoning mouth parts that look like kind of a coiled tube, and it'll act as a straw that they can go ahead and insert into the nectar reservoir of a given flower. What's really interesting to me as an entomologist is a lot of lepidopterans, a lot of other butterflies and moths, they may not actually consume food. When they become adults, they may lose their digestive tract and their mouth parts because their sole purpose in life is just to mate, lay eggs, and die. However, monarchs, since they migrate, need the energy. So they're going to have that coiled tube. You're going to be able to see it very visibly on a flower as they begin to feed, and you can see I've highlighted it here in this image. One myth that I like to dispel with people too is that it is physically impossible for any butterfly or moth to actually harm you. You've probably heard a variety of urban legends on how they may be able to drink blood from other animals or do a variety of things, and trust me when I say these are about the least harmful insects you can find out there, so long as you don't eat them, of course. So we've covered how they feed, we've covered how their color works for them. Now let's cover their typical life cycle. Now they are like a lot of butterflies and moths, wherein they're going to go through an egg stage, a larval stage, a pupa, and an adult. So let's just go over that step by step. So let's start with the adult. You're going to see the adults flying around during various portions of the summer, and they are going to lay a single egg on an individual milkweed plant, because what they're doing there is they're guaranteeing that that young has the best opportunity to get the most food. So they're not going to crowd a plant with eggs. The eggs are going to hatch after anywhere between 10 to 15 days, depending on how warm it is, and the caterpillars are going to go ahead and begin consuming that milkweed plant. Now they're going to go through several molts where they'll shed their skin and grow bigger. We typically refer to this as an instar, the space of time between moltings. So larval instars is a common term you may hear entomologists use. As they consume their food throughout their lifespan, eventually they'll get big enough where they will form a chrysalis, sometimes referred to as a pupa. And when they form this chrysalis, they're going to kind of go through a strange process where they break down their body and reform it into their adult form. And all of this is going to take place within the space of a summer. They are not going to be overwintering here with us. They are going to then move down to whatever monarch grounds they have. And we're about to head right into that topic right now. So this just kind of breaks down what I was just talking about. We can see the eggs laid on the host plants. We can see that the larva, in this case, has 5 instars for this insect. And if you are interested in locating pupa for the monarch, they can normally be found hanging from the host plant. So if you look back at the previous image, at the bottom of the image you can see what the appearance of the various pupa there. So this is what you're going to be looking for. The early stage is going to be that kind of greenish color there, and as it keeps developing, you're basically going to see the monarch adult kind of enclosed in that pupal case, and it'll look more and more bright as it gets closer to actually hatching out of its pupa. And then you're going to see them hatch out after about 2 weeks of time. But again, this is dependent on temperature. Like most insects, the warmer it is, the faster they will develop. Okay, so their yearly migratory pattern. This is perhaps one of the most interesting subjects when it comes to monarchs. With monarchs, there are 2 major breeding groups. There's one west of the Rockies, and there's one to the east. The one that's west of the Rockies overwinters in Southern California, whereas the one that's east of the Rockies, namely the one us here in Indiana are going to be seeing, overwinters in Mexico. When they make their trip northward during the summer, they take a multi-generational migration flight northwards. And I'm going to break that down just a little bit here. So if we start at our F0, our starting adults in Mexico, they are going to be what I call our F0 generation. They're going to start moving north, and they're going to eventually arrive in areas like Texas. Now, they're going to live probably until about May. They're going to make sure that they produce our F1 generation. And that F1 generation is then going, from May and onwards, is going to start flying northwards into places like Canada, the Midwest, here in Indiana, as well as the eastern seaboard and into the New York area. As they do so, they're probably going to give birth to yet another generation, our F2s, because these are insects. They're not going to live a super long time, at least not these particular insects. And when they eventually arrive at their destination, they're then going to be giving birth to their F3 and F4 generations. So we've got about a total of 5 generations there just for the northward flight. And each generation is going to be a little bit different. If they're making huge trips northward, they probably aren't focused so much on breeding as much, but energy, because they need to make that flight. However, when they arrive at their destinations, like here in Indiana, that energy pattern may shift, where they're not focused so much on flight, but they're focused on reproduction, so they can produce that next generation, because at the end of our summer, as a lot of us already know, they're going to start that flight back southwards. Now, this is just a great image I wanted to include here, because you may rarely see this in Indiana when they arrive, but this image is actually taken from an Oyamel fir tree in Mexico. This is where these insects are all gathered and where they overwinter. And if you find the monarch preserves in Mexico and actually get the chance to see them, which I highly recommend, they will be so thick on the trees will actually be drooping, and you can see them just covered in monarchs. It's a trip I myself hope to make one day. So we've gotten to the point where they have made it to their stopover points. They have gotten to their summer grounds where they're going to be reproducing, and we can see them here in Indiana. Well, as the summer begins to come to its close, they need to make the flight back south. So those F3 and F4 generations are going to stock up on all the nectar and all the energy they can get. These are those caterpillars that you've been seeing in Indiana who have now developed into their adult forms, and they're going to fly back southwards, just like using the same path they took northwards. When they get to the point where they're getting into the southern or the southwest United States, they're going to go ahead and produce that F5 generation, and that is going to be your overwintering generation. So it's going to be a whole different group of monarchs that are going to arrive in monarch preserves in Mexico, and they're going to overwinter in those Oyamel fir trees. Now, one last thing that I want to cover here is that there are some other insects that look a lot like monarchs, and this is a great example right here. This is our viceroy butterfly. This insect shares a lot of things in common with monarchs. However, they don't eat the same food, and they don't do quite the same things. Let's do a quick comparison between the two images. We have our viceroy butterfly right here, and this is our monarch. Look at the wing pattern. Look at the different colors, the orange spots and other things on the wings, and compare them between the monarch and the viceroy. You can see they're just a little bit different. Some of the body coloration is also a little bit different. What's going on here is an example of something known as Mullerian mimicry. Now, you'll hear a lot of biologists and entomologists talk about Batesian mimicry. That's the kind of mimicry where an animal tries to pretend it's something much more dangerous than what it actually is. One example would be what here in Indiana we call the sweat bee, but in reality is actually a type of flower fly that pretends to be a bee. It pretends to be much more dangerous than it actually is. They can't sting you, they can't even bite you. In the case of the viceroy butterfly, however, Mullerian mimicry means that it is something that's dangerous, and it's using its sister species, the monarch, to enhance the benefit of that danger. The viceroy butterfly sequesters salicylic acid, making them extremely distasteful, and they get this by consuming plants such as willow and cottonwoods. So if they get consumed, they actually are really distasteful or unpleasant to predators. So the monarch and the viceroy are kind of pulling from each other's own defenses, and they're enhancing them at the same time, because now the predator is just going to look at both of them and go, neither of these is great. I'm going to avoid them like the plague and stay as far away as I can. Okay, so one thing that I wanted to share with all of you, there are a lot of monarch preservation organizations out there. I'm showing you Monarch Watch's homepage right now because there are a lot of members of Monarch Watch in my local area who do some great work helping preserve monarch species. The other reason I wanted to show you is because you can get milkweed from them. In Tabby's talk that you'll be seeing in the next video, she's going to go over the different kinds of milkweed you can plant, and this organization will help you get in contact with milkweed producers and have all sorts of different kinds. I myself prefer butterfly milkweed because I am a terrible gardener and I just love things that are easy to grow that'll work for me. But there are several different choices that you can look at and choose the right ones for your property if you're interested in helping to protect monarchs. It also gives you the opportunity to help contribute the data that this organization will use to continue its preservation efforts. And again, there are several organizations like the Xerxes Society and others who do this same kind of work. Okay, so I've got my contact information here. You can call or email me anytime. I also have links to the Purdue Ed Store, which has a lot of great publications to help you figure out how to help your monarchs or any other problem you may be experiencing, as well as a link to our Purdue Plant and Pest Diagnostic Lab. They can analyze just about any plant or insect sample you send them and help you figure out what's going on. And with that, I want to thank all of you for watching today's video. I hope you enjoyed it, and please let us know how we did in the comments, and please like and subscribe, and we can keep you updated with more information from Purdue Extension.